again here with your 6.04 recording. So today I thought, well, normally I would have you private chat this to me, but obviously you cannot private chat it to me. So I want you to look at this problem. I want you to figure out where did Michael make his mistake and what is the correct answer. And then I want you to pause and I want you to come back to see if you were correct. So pause it now and then we will continue on with where the mistake was made. Okay, students, hopefully you had enough time to pause and that you came back and you're joining me now. So remember when we do a problem like this and we're looking at factors of 6, right, to give us 5, is it okay that we have it set equal to, that we have it equal to 2? Is that okay? Or do we have to get it equal to 0? I want you to think about that for a second, because all the problems that we've dealt with have either been perfect square trinomials where we could take the square root of that side, or it's been set equal to 0. So does it make sense for this to work? And if it does, where did we go wrong? Right? So factors of 6 that add to give us 5. Looks like things are correct, right? So if we assume that we can have it equal to 2, then let's check and see if there's any other mistake. And if we can't find a mistake, then maybe we can come back to that point, okay? So 6, factors of 6, we see that we have 3 and 2, which are correct. They multiply to give us 6, but they also add to give us 5. And you can see that we've put a negative and a negative because this middle term is subtract sign or negative, right? Okay, so then we know that each one we set them equal to whatever's on the other side. Normally that's 0, and we've only done it with 0. So what they've done is said x minus 2 equals 2, and x minus 3 equals 2. So then they added 2 on the first one and got 4, added 3 on the second one and got 5. So it appears like if you can have that equal to 2, that everything is done correctly. So my assumption is then that Michael forgot to subtract 2, right? Forgot to subtract 2. But what happens if we subtract 2? Ooh, then we have factors of 4 that add to give us 5. Do we have factors of 4? Yeah, we can do 4 and 1, and those add to give us 5. So I'm pretty sure that is the mistake, and hopefully that's the mistake that you caught as well. All right, you guys, today we're going to focus on lesson 6.04, and it's titled Probability with and Without Replacement. So we are still using that probability, that idea of a part of something over a whole. So a part of a situation over all of them. Okay. All right, real quick, our calendar items, just remind you that I'm zeroing out the grade book next week, next Friday. Don't forget, no live class the rest of this week. So hopefully you'll watch the recordings. There will not be a recording on Friday, but other than that, you should have one Monday, Tuesday, or Tuesday, Wednesday, and Thursday. The other thing to note is everything is due by midnight for my class on the 24th. So hopefully you're getting caught up and you are where you need to be. Okay. Objectives for today. So our objective is I can use multiplication principles to find probabilities of compound events with and without replacement. So this is key right here, multiplication, right? So we're going to be doing a lot of multiplication today. And the other objective is to use tree diagrams to find probabilities. So when you look at some of these questions, you're going to see lots of words, right? Lots of answers that look like this with a percentage, okay? You'll have a couple tree diagram ones like you see here on question 1 and 2, and they're asking you certain probabilities about those. With that being said, let's continue on. Okay, so for our information to save page for 6.04, these are the things I wanted you to remember. multiplication rules for probability. For events A and B, where A occurs before B. Okay, so this is like saying, I have a situation, I'm going to do this one first, and then I'm going to do this one, okay? If there is replacement meaning we're going to put it back, or we're going to include it the second time, then this is how we read it. Probability of A and B, so there's that and word, meaning multiplication, equals the probability of A times the probability of B. Okay, so we take the probability of the first event and we multiply it by the probability of the second event, knowing that there is replacement. Okay, now I want you to look at the next situation if there's no replacement. What do you notice is different? What do you notice is different? Obviously, I can't wait for your responses, but hopefully you said something like, oh, well, there's a B after P, right? Or after A. Yeah, there's this crazy thing in there that you're like, what? So this is if there's no replacement, meaning we're not going to put it back in. So I take out a marble, I leave it on the counter, or I pick an apple and I eat it. Okay, obviously it's not going back in the basket, right? It's not going back in the bag if you leave it out. So this is probability of A and B. So there's that and again. We still use multiplication. Equaling P of A times P of B after A. So that means you're not going to count what you did the first situation. The first probability does not count in the second one type thing. And this is, remember, with no replacement. Okay, so some notation. P, so right here, I'm looking at P and then B after A means the probability when event B follows event A, and there is no replacement, okay? So a little tip, from now on, when a problem says without replacement, assume that it means that the result of the first, I can't see what that says. I think event is not known, okay? So we'll talk about what that means. And I can't see it because my head's in the way. My camera went right there and I can't move it, so hopefully you can see it. If you can't, I will minimize that once it's over. All right, so some questions. This is finding probability of compound events. So compound meaning more than one, a couple events together maybe, with and without replacement. So you're going to look for these keywords like putting it back or replacing it, or the other keywords on the opposite of that would be leaving it out or not replacing it type thing. So here's an example. A bag contains 4 black marbles and 2 red marbles. So let's draw a visual of this. Here's my bag. I should have made this brown, although I don't see a brown. Okay, here's my bag. We have 2 red marbles inside this bag, and we have 4 black marbles. You guys are loving my drawings. I know you are. Those look so much like marbles. Okay, Felipe, yeah, what the name, right? Randomly draws a marble and does not replace it. Okay, there's key. Does not replace it. Okay, so that means he's going to take it out and he's going to leave it out. Okay, so assume Felipe draws not looking at the results of his, okay, assume that Felipe does not look at the results of his random draw. Okay, so he's going to reach his hand in there and pull out 1 marble, okay? Then Paint randomly draws marble from the bag, okay? What is the probability that both marbles drawn are red? So this is where students are like, okay, well, there's 2 red in there, so the chances are 2 for the first time and the chances are 1 the second time. Okay, but remember, this is a probability. It's a fraction. So we have to take the choices, the amount that we have in there, over the total. We always have to deal with the total when we have probability. So remember how we had that on the last slide, we had the P of A times P of B? Yeah, that's what we're doing here. So the probability of the first event would be Felipe, right? And so we know that there are 2 red marbles in there out of a total of 6, right? Because there's 4 black and 2 red. And now he's gonna take out 1. Let's assume, okay, even though we don't know this is the case, let's assume he gets out a red one, okay? So he's taken this out. It's gone out of the bag with Felipe, okay? So now we only have 5 marbles left in the bag because he's not going to put his back in, and there's the chances of only having possibly 1 red one in there. Now, do we know his is red? No, not necessarily. So why aren't we saying 2 again? Well, what if his is red? So we have to take, I don't know, have you ever heard like the worst case scenario or maybe the best case scenario? So depending on whether he wanted a red or not, so we have to take like the worst or best situation, whatever you want to, however you want to consider it, whether you like red or not. I don't know. So when we take that out, we have to consider that it could be a red. So that's why we have to do 1 out of 5 now. Now, if it was a black, it's a black, right? And our chances were still 2 out of 5. But we can't assume that. We have to assume that the situation was we got out a red, okay? Now, we don't know that for sure, but remember, this is a probability, and probability is like the chances of this happening, okay? So what is the probability that both marbles drawn are red? And that's why it's key. That's why I have to use just the red marbles, because I want both of them to be red. Okay, so hopefully you understood that. Now, we just multiply. So this would be 2 times 1, which is 2, and 6 times 5, which is 30. So my chances, I'm going to reduce that to 1/15th, are very unlikely, right? This is pretty low percentage. But if I was going to go ahead and grab my calculator and do that as a decimal and then percent, so 1 divided by 15 is 0.06, and then it goes on forever. So we're going to put 0.067. And so now when I do move my decimal, you guys probably are already doing this, but you should get a 6.7% chance of that happening. So 6.7% chance that they're both going to draw a red marble, knowing that Felipe didn't return his. Now, this might be the next question, and I can't go forward and come back. So let's go to the next one, and nope, it's not. So on the previous question, if it would have said he replaced it, he put his marble back in. So he looked at it, recorded what he got, and then put it back in. The second probability would still have 6 marbles and would be 2 out of 6. So your chances of it happening now are more likely, right? Because you have more red in the bag. All right, let's try another one. So this one says Joni, that's how I'm gonna pronounce it, and Chachi. Where they came up with these names, I don't know. Our friends, Joni and Chachi are friends. Each has a box that contains 3 raisin cookies and 5 lemon cookies. Yeah, I don't really care for either one of those kinds. Why they didn't pick chocolate chip and oatmeal or something like that, or peanut butter, I don't know. Without looking, because it would make us probably too hungry, Joni takes a cookie from her box. This first cookie is lemon, so she puts it back, mixes up the cookies, and picks another cookie. The second cookie is lemon as well. What is the probability of Joni's 2 lemon cookie outcome, which was with replacement? So they didn't really need to tell us it was with replacement because, hello, we saw that it said right here, she puts it back, right? So there's our key to know she puts it back in. Now, obviously, she got both out, so we would assume that the probability is pretty high, but we want to know what her chances were if we were thinking about this before she did it, okay? So we start out with the total. I always start out with the total, you guys. It just makes more sense to me. So I like to draw the 2 lines with a times sign in between because that's really what we're doing on all these probabilities, right? We're combining these probabilities. We want to know this and this together. Okay, so I'm going to put the total number of cookies on the bottom. It said that there were 5 lemon and 3 raisin, so I know I have a total of 8 cookies in the box. So I'm going to write 8 there, and guess what? I can put another 8 here because it says that she put it back in, so I'm okay to put 8s on both of them because that is the total for both. The first time, we have the chance of 5 lemons, right? So some students will want to put a 2 somewhere because they see that she's picking it twice, but that's not the case. You always have to go back to what the probability or the possible chances are of that happening. So we go back up here and we saw that there were 5 lemons. So I'm going to put a 5. Guess what, you guys? She puts it back in. So there's still 5 lemons in the box. So our chances are 5 eighths times 5 eighths. All right, so now let's multiply. 5 times 5 is 25. 8 times 8 multiplication, I hope you remember this, is 64. And so we have a 25 out of 64 chance of that happening. Now, does that make so much sense to me? No, not really. Like, okay, that I could say, oh, is almost half, right? 25, half would be 32-ish, so we're pretty close to half. But for it to make more sense to me, I like to change it to a percent. So this is 0.39 as a decimal. And then I move my decimal 2 places and see that we're pretty much at 40%, right? 39%. So it's a 39% chance, which is getting there to about equally likely, right? So you have highly unlikely or unlikely. You have equally likely, and like 100% chance would be 100%. It's happening. What's the other word? Unlikely, equally likely, and likely. Likely would be that it's above 50%. Okay, continuing on. Now, I want you to try this one. So I'm going to have you pause, and I want you to pause it now. So pause me, and then you can come back and listen for the or see the answer. Okay, students, here is the answer. You can see that I put 5/8 because there were 5 lemon cookies and the total in the box were 8. But then it says that he likes them, so he ate his lemon cookie. And so now there are only 7 cookies in the box. That's why it's out of 7. And only 4 of them now are lemon. So the probability or his chances of this happening is less than what we had on the last one, right? Which makes sense because there's 1 less lemon cookie and 1 less cookie in the box. So we get a 35.7%. Hopefully you got the same answer. All right, so what happens then if I'm given a tree diagram? How can I find probabilities from here? This question says, you're at the arcade and begin with 6 quarters and 4 tokens in your pocket. Okay, so you have 6 quarters and 4 tokens. You randomly choose a quarter or token, use it in a machine, and then randomly choose another token. Fill in the tree diagram below. Okay, and I know that you'll have questions like this where you have to fill in tree diagrams, and so let's make sure we understand here. So the first action, or the first experiment, you can say, event is another word we've been using, is to choose a coin. Okay, so we'll say we're going to choose a coin. The coin could either be a quarter or a token, and so that's where these number quarter and token come into play. Okay, now we know that there are 10 total, and so that's where these number 10s come from, because up there in the beginning of the problem they say that there's 4 and 6, and then we know that there are 4 tokens, so that's why 4 is on the top, and 6 quarters. So those are basically your probability of getting a quarter would be 60% and 40% for a token, right? More quarters than tokens, it makes sense. Now, the second action or event would be to choose another coin. So you have the probability of getting a quarter or a token again. But we already chose 1 quarter. Okay, so if we're looking at this top line, we already chose a quarter. So now the total is 9, right? You can see that the 9 is on the bottom of all of these in this second action because we've taken that coin and we've put it in the machine. We no longer have it in our pocket. But how many quarters then do we have if we're going to assume we get another quarter? Well, we only have 5, right? Because we already used that quarter. How many tokens then will we have if we used a quarter? Well, look, because it says quarter right here, we can assume that we got a quarter out, and so now we still have 4 tokens in our pocket. So our chances are still 4, but out of 9 because there's 1 less coin. All right, so then going down to the token side, it's kind of going to be flipped, right? It's going to be opposite. We're assuming we took out a token the first time on this one. And so now there's 1 less token in our pocket, which means if we're going to get a token again, which is going to the token line, there's only a 3 out of 9 chance, right? But there's a 6 out of 9 chance that it's a quarter this time, because we still have 6 quarters in our pocket. We didn't use the quarter the first time, we used the token. Okay, so that's how you find probability when you're dealing with a tree diagram. It's kind of like a picture of it, right? Okay, and that's it. So pretty short video. I had you out of here in 20 minutes. You're welcome. Your assignment 6.04, complete it now. You do have 3 attempts, but I'm not here to ask you for you to ask me questions. Hopefully, you don't have any. If you do, please send them my way through email. I will try and check it as I'm testing, but I won't make any promises because testing will be my priority tomorrow or today, since you're watching this today. There is your attendance ticket password. So make sure you type it in exactly how you see it here. And, ooh, my pen is going crazy. Let's get rid of that. Please let me know if you have any questions. You guys are awesome. You did great on your assignment from yesterday. I didn't put up your yesterday's review. I probably should have, right? That would have been fun to see because I didn't have any of you there to feedback with, but it was at an 80% average. So very pleased, very happy with how you did. Keep it up. You're doing awesome. Let me know what questions you have. Thanks, guys. See ya. Have a good one.